Well, welcome to the January 2026 meeting of the Mornington Peninsula Astronomical Society. And for those of you who've either been on Facebook or email, you probably would have realised there was an aurora last night that was seen up as far as Canberra, as far as I heard. I hadn't heard whether it was any further north than that. Plenty of members were down here at the Briars. I wasn't one of them. I was tucked up in home. We could see it by eye from Frankston as purple rays in the sky with green underneath it. But Jamie Pole with his Canon camera took this video, which I'll first of all show. It goes for about a minute or so, which is down there on the property looking to the south. If you notice very carefully, if I turn the middle light off, you'll see the Southern Cross on the left-hand side of the screen. And the two pointers. You probably saw an aeroplane just flying through the Southern Cross just then. And you get the green lower to the horizon, and the blues and the purples higher up above it. Interestingly, not really much red there at all. And Jamie took that from about dusk until around about midnight as a series of photographs that he's stitched together to make this short movie. And plenty of fantastic shots by members across the peninsula taken with their own equipment. So very, very well done. Here at the Briars, the all-sky camera is the top right-hand side view that picked the aurora there. The orientation of it is that if you take the top right-hand side and rotate it by 90 degrees to the left, it will correspond with the orientation of Jamie's photo there. So the green on the all-sky camera is up at the top left, which is the green that is flicking away to the left of the trees there. And over on the other side you see the blues and the purples, and you see a sort of a ray come up as well, which is very spectacular to see. And you can see on the all-sky camera there that Orion is in the centre on the right-hand side as well. And you can see the Southern Cross and the pointers on the top left-hand side of the all-sky camera. Now, I saw today that Phil Holt in Mornington, using his hubcap camera, using a truck hubcap, successfully caught similar sort of view. I think he got it at a stronger burst at the time as well, and he posted that to eScorpius, and I noticed that just as I was leaving home to come here. So lots of things happening in the sky. In the next few days we've got Artemis 2 due to launch, all being well. Of course, rocket launches are notorious for being scrubbed for one reason or another, and there's all manner of reasons that could cause it to be scrubbed. Shown in the bottom left-hand side there is the crew of 4 plus the 2 backups, and you notice that they have 2 people of colour and 2 women in there, so the backups are woman for woman and coloured person for coloured person, so they're very, very diversity and inclusive conscious, which is quite curious in the current political environment in America. But nevertheless, 4 of those are going to be sitting on top of that rocket. The launch window is between February 6th and April the 6th, but it's only certain days that they can launch, and the reason for that is the position of the moon relative to the Earth. Some days are actually it's less efficient of making the journey that way, so they specifically have to launch it on certain days. I've just been waiting for somebody to say online somewhere that if it's a crescent moon, they don't want to aim then because there's less of a moon to aim at, right? But you'll see the orbit. I'll show it in a moment on another slide. So as things stand at the moment, I think they were going to do a wet test or a wet launch or something like that, which is like a bit of a dry run, and I'm not sure why it's wet, but maybe they get a bit worried by that. And if everything is all okay, they'll launch on one of those windows. But all sorts of things can occur. If there's a 20% chance of lightning within 20 miles, they'll abandon it. If the temperature's above a certain level, they'll abandon it. If there's any leak whatsoever, they'll abandon it. If it's too cold, they'll abandon it. If you remember the old space shuttle that blew up because it was too cold for the O-rings, well, they're very, very aware of that. Because incidentally, the rockets shown there as part of the Artemis is actually previous space shuttle rockets, so it's the same technology being used to launch Artemis. Now, Artemis 1 went in 2022 around the moon unmanned, and this is the first one that is going to have astronauts on board just going around the moon. So those of you who are my age will sort of say, yeah, but didn't we do this well over 50 years ago? And the answer is yes, we did. We're learning it all again with the latest technology and a new batch of people in the job. And probably even the computer languages aren't the same these days to what were actually used back in the 1960s and 70s when they were working on that. And they've just fairly recently crawled it out to the bottom right hand side using the crawler, and yes, it's the same crawler that took the Apollo spacecraft over 50 years ago. So this bit of machinery has like a couple of locomotives in it equivalent, and we showed this in one of these meetings a few years ago now. You see the size of it, it's quite a large thing to actually be moved, and if they scrub the mission, they will crawl it all the way back into the vehicle assembly building. The one that, if you remember, it can only travel at 1 mile an hour or 1.6 kilometres an hour, so it takes them about 12 hours to actually go from the building to the launch site, so they don't do that unless they really have to. But you know, if a storm is coming or something like that, they'll turn it round and go. If there's any chance of lightning, then they won't even fill it with the propellant because they're obviously worried about the possibility of lightning strikes. Now, Artemis 1 in November 2022 went round the moon, and it didn't come back until the 11th of December, so they were checking the systems as best they can remotely. So it flew a couple of times around the Earth and then went off around the moon, and they had a dummy on board sitting in the pilot seat, and they also had a model of Snoopy on board as well. And this is what we actually show for any of the kids that are interested in seeing Snoopy going to the moon. We actually ask them to see if they can spot it, and I'll play this. It goes for about 2 or 3 minutes. the flight plan for the Artemis 2, which is the one coming up in a few days' time, all being well. Just follow the numbers, starting sort of on the left-hand side at the top there with number 1. It'll launch from Cape Kennedy, basically make a couple of orbits of the Earth while it's having the systems tested, because one of the objectives of this is to actually test the life support system. And if you're one of the 4 astronauts on board, you'd like that to be a success, because once you're on the way to the moon, there's no way of coming back, right? Because it's a one-way journey. They don't have the fuel to change course themselves. It's a free trajectory. So when you follow the numbers around, the green numbers, after you get round to number 9, and that's when they make the decision to do a translunar injection. So in other words, they fire the rockets to fling it off to the moon. So it follows the green path round to 10 and 11. It loops around the moon and then comes back. So they're not firing rockets along the way anywhere. They're relying entirely on the gravity of the Earth-Moon system to take them around the moon and bring them back. So if even all the propulsion systems were to fail and they couldn't do anything about it, the craft will still turn around and come back. The only trouble is that coming back is like a 4-day journey. So they've got to at least survive for that period of time. So you don't want something like the Apollo 13 mission, which did a similar sort of thing. And if something goes wrong with the oxygen supply of that, then you could be in serious trouble because your time runs out. So it comes around and then basically lands. So very, very similar to the way that Apollo went to the moon, except that it wasn't just going around and coming back. So they're not going to land on the moon. It's just going around in the same Orion craft, testing it to make sure it's okay. And then Artemis 3, the one after that, if this one is a complete success, then they'll attempt to land on the moon. And the timeline for that is end of 2027, although they think that that is probably optimistic to actually get ready for it. All right, there's a question, Fred. If you shout it out, I'll repeat it so it goes on the recording.
You said it was a one-way ticket to Sonic Galactica. What's the actual objective of this Artemis?
Well, when I say it's a one-way, ticket, they are coming back, but they have no control of coming back earlier. So, in other words, if they're a third the way to the moon and something goes wrong, they can't just turn around and come back, right? Because that would require you to fire rockets to fight your way back, right? To give yourself propulsion. And they don't have that capability. So all they can do is rely on the moon and the people back at home who've done their calculations, and you hope that those calculations are right, so that you hit the moon at the right spot and then come on back. And yeah, so they'll obviously test the manoeuvres like you actually saw in Apollo, where you know, you had the lunar module and the command service module, and it came out and they turned around and they docked and those sort of things. They'll be doing testings of those manoeuvres as well, and you can see some of the scheduled trials over on the left-hand side, on the right-hand side in the box there. Yes, Sylvie?
If life support fails and they've gone around the moon, so from Earth they're able to
yeah, so if the life support fails and they die on the way, they will end up coming back, because it is able to be operated remotely. The same as they fired Artemis 1 and took it round and landed it, they would do the same. The only difference is this time, of course, that they're going to try and test the manual controls of the spacecraft. So on board is the 4 astronauts going on the way. 3 are from America and 1 is Canadian, from the Canadian Space Agency. All right, now welcome to the meeting, and if we've got any new members here, our secretary is not here tonight, so I don't have a list of new members in the past month or two to read out. We'll do that next meeting. If there are any members who've joined recently, I know there was at least one, welcome, and I'd ask any members of committee to put their hand up so that you'll know who to ask when you go out for a cup of coffee. Yep, don't feel shy. I'll talk as usual about the past and coming events. Sky for the month will be given by Guido then, and then we'll look at the First Astronomers, the Indigenous talk that Associate Professor Duane Hamacher gave us back in late August last year, which we haven't shown here. For those members, I've received 5 or 6 requests to play it to other members who couldn't come on a Saturday. Here we are. So it'll go up on YouTube as well. And then we'll look at when Apollo was had its budget cut by the US Congress. Apollo 17 was the last one, even though they'd already built Apollo 18, Apollo 19, Apollo 20. Those rockets had already been built, ready to go. And when the money was pulled on it, where were those missions going to be going? And then we'll look at that. From Amy Shearer-Teasle, who's visited the Briars in the past here before, and we'll look at what those ones were. And then we'll close with a view of the moon for all of the year, every hour. All right, so the recent events there. We had, right at the very bottom, on the 16th of January, we had a visitor from Canada, from Calgary here, from Rothney Astrophysical Observatory from the University of Calgary. He's a volunteer astronomer there, and he visited us, and he may indeed even turn up tonight here. So he was keen to come and have a look, and he's probably a bit unhappy that he missed the aurora last night as well. Way back when we last met last year, we had a committee meeting on Zoom that was talking about all sorts of things: the almanac, the lease, the Brian Cox visit later in the year, and the solar banner. And you see Dave Rolfe got this solar banner made for us over on the right hand side, which we'll be using, for example, on daytime astronomy that we do, like one coming up in February on Frankston foreshore. Later in November we had 3 scout groups here at the Briars, and unfortunately they were fully clouded out, but they had a good time. Lots and lots of public nights between now and then, and the concert went ahead on the 6th of December as planned. Obviously we had the dinner here for those members who were able to come, and a good time was had by all as usual. Then a swag of public nights, including the one on the 10th of January that had to be postponed a day due to the extreme fire conditions at the time on its scheduled day. Nevertheless, we managed to get 52 of the 90 odd people booked to turn up the following day. And some of them were overseas tourists and tourists from Sydney. So if you miss the window while they're down here, too bad, they can't come back at a later day. And we had several of those. So coming up soon, this Saturday we've got the Working Bee and Members Barbecue at the Briars at 4 o'clock as usual. Committee meeting next Wednesday at 8 p.m. The Cosmology Discovery Group on Saturday the 31st of January at 1:45 as normal for members who wish to see come here for that. 6th February, the next public night is booked out, and Trevor should be back from his sailing the South Seas talking. So he's currently talking on cruise ships about astronomy. 7th of February is the Frankston Waterfront Festival, where we'll set up the MPAS marquee, and it's pretty much an all-day event there. It'll be telescopes, but no talks, and the new solar banner will come along to that, no doubt, unless it's a rip-roaring wind on the day, which might threaten to shred it. 14th of February, the trivia concert will be held here at the Briars with the Cranbourne Lions concert band, and so far we've got 33 people booked for that, and I think they've just turned on Facebook advertising recently, so hopefully that will boost some extra numbers there. I missed on 13th of February, we've got the next Indigenous Stargazing Night here and talk by Tim Paxton, and at the moment it's fairly small level of booking, only 2 booked for it, so we've also I think just turned on Facebook advertising for that as well to see if we can boost that, because that's unusually low as is. Coming up, not this month, but next month, we've been invited down to the Inverloch Equinox Festival, I think was the name of it, which is in collaboration with the Latrobe Valley Astronomical Society. Normally the ASV would participate as well, but they were unable to this time, so we'll be sending a few members out there with telescopes to talk over the two days there. And simultaneously on the Saturday, 21st of March, the Telescope Learning Day, and we do 2 of those every year, it will be here at the Briars, right? So that is just giving you an early heads up.
All right, so sky for the month for January and February. So let's look at the solar system first. So here's a look at the inner solar system, I think today or yesterday. We have, what do we have? We have Earth around here, Sun there, and you can see Mercury and Venus basically hiding behind the Sun there, and Mars also pretty much out of view. So if we then zoom out a bit from here in a second, and look at the outer planets, then we have, as you can see here, Jupiter basically at opposition or just past opposition, so right opposite the Sun from us, and Saturn actually getting pretty low in the early evening sky, so sitting pretty early now. So that's the situation at the moment. I think we can fast forward through the next month or so. So we'll see, especially what's happening in the inner solar system. You can see Mercury and Venus will eventually come back from behind the Sun. We will see that in the all-sky view in a minute as well. But Mars basically stays hidden behind the Sun for the next couple of months. Yep, and you can see there Mercury almost heading for its conjunction with the Sun there. All right, so let's have a look at the evening sky on the 1st of February. So the Sun is setting, well, we have Venus now past its superior conjunction. It's going to be an evening object from March. Mercury is basically at superior conjunction, so between us, behind the Sun from our point of view. Sunset around 8:30 p.m. On the 1st of February. And then in the early evening, just after sunset, we still have Saturn in the sky there. So you can see Saturn, Neptune still there in the west, but basically setting pretty early now. And Mars is, as I said earlier, too close to the Sun to observe. So if we now fast forward to around 10 p.m., you can see Jupiter there. It's now past opposition, but still in a very good spot to view. We had a really nice view of Jupiter last night from here as well. And Uranus is very low in the northwest, but also still in the sky at least. The moon we'll have next. We've just had the new moon a couple of days ago. The next full moon will be on the 2nd of February, and then the February new moon on the 17th of February. All right, so this is again at around 10 p.m. the main stars. So you can see that Orion, so Betelgeuse, Rigel, now very prominent in the evening sky from actually just after sunset, and of course Sirius, Canopus, the two brightest stars, also very, very recognizable there. The Southern Cross relatively low around 10 p.m., but then getting higher from as the night goes on. So yeah, and I think we basically had the constellations there. So yeah, the Southern Cross down here, relatively low, and then Orion as the kind of dominant constellation rising in the east, actually before sunset now, yes. All right, and then there's not much going on throughout the rest of the night, so no more planets to see. But yeah, you can see that Orion will set kind of in the early morning. We've got one comet here in the view. I'll mention that one on the next slide as well. And I think sunrise is around 6:30 or so. What do we say? Yeah, 6:30 on the, in this case, the 2nd of February, I guess. And yeah, you can see here how close Mars and Venus are to the Sun at the moment. So completely lost in the glare there. The apparent sizes of the planets, if we could see them, so Jupiter obviously very large at the moment, as it's just past opposition, so we're still very close to Jupiter in its orbit at the moment. Saturn, if we can still see it, like, or when we can see it just before sunset, you can see that the rings are opening up again a little bit now, so that will continue to happen throughout the next few months. But yeah, it will set earlier and earlier now over the next few months. I only found 2 comets that are brighter than magnitude 10 at the moment. So C2025 A6 Lemon is low in the southeast in the early morning. And we have 24P, and I don't know how to pronounce that name. I know how I would pronounce it in German, but I don't know. So that one, Schormas or Schaumasse, I don't know. So that one's around magnitude 9, also low in the northeast in the early morning. So both of them maybe not the best targets. The interstellar comet is heading, so 3I Atlas is heading out of the solar system, and it's very faint now. Both Greg and I tried to image it about a week or 2 weeks ago and just couldn't see anything. So I'm not sure if that's still even useful to try at the moment. We've got one meteor shower, the Alpha Centaurids, from the 28th of January to the 21st of February, peaking around the 8th of February. And that one can have bright yellow and blue fireballs. Not a very high rate. I think I read something like 5 per hour or so around the peak. But it can also have long-lasting trains, so it could be a good one. Unfortunately, it's affected by the moon. The full moon is around this, I think, the 2nd of February, as I said earlier. So this one is peaking around the 8th, so there will be quite a bit of light in the sky from the moon around that time. All right, and the sources, as always, Stellarium and NASA Eyes on the Solar System, but also Astronomy 2026, which we didn't expect to have, but they... I think many of you know, because I think Greg posted that on eScorpius as well. They released an updated version for 2026, but only as an online ebook, as a PDF. But the advantage is it's free, so you can just download it from the website if you're interested. And that's all for this month.
Up on the shelf next to that globe, there's a hard copy of that magazine.
Of the 2026 one? Oh, okay, so...
It's in a plastic container just to the left of there.
So printed copy, if anyone wants to have a look at a printed copy. Great. Phil?
Yeah. Refresh my memory, how many days does it take for Mars to go around the sun?
I think it's something like 600 or so, isn't it? Order of magnitude.
Lower than us?
Yeah.
You're opposite the sun on the other side, right?
So it's yes. So we are catching up with Mars, basically, right? So we're going faster. So eventually we will catch up, and then it'll reappear, basically.
And how long will we see Jupiter for?
For the next few months. So that, yeah. So basically.
Saturn's just about another couple of weeks, is it?
Yes. So Saturn's basically gone. I think next public night we probably already won't have Saturn anymore, but Jupiter will be there for quite a while. Yeah. All right.
Actually, before I'll do this, I'll mention something that Ian Barry mentioned to me just before. He was just like to point out that Australia Post has released 2 sets of stamps for Sydney Observatory and Melbourne Observatory. And if you want to come and hold them up, Barry, or give them to me to hold them up. Yeah. So if anyone is interested, I think they're cover sheets. That's the Melbourne. It looks like Melbourne Observatory.
Melbourne and Sydney.
Yeah.
It's just $3.70 stamps. I don't know whether they're actually out for public use or not yet. I don't know what the rules are on.
Yep.
And that one's a medallion. That's about $35, mainly about the GMT. And that's the only reason I got it. I gave up stamp collecting 60, 70 years ago. So I went and got these because I did work on the GMT until COVID hit.
So for those that don't know, the GMT is the Great Melbourne Telescope that the ASV is doing up in conjunction with the museum.
Or incidentally, I saw on a program, Landline or something like that, years ago, about this vineyard up in Canberra, and it turned out to be Brian Smith's. So that's his part-time job, shall we say, as well as being Vice-Chancellor of ANU. And it was all about, never have there been so many PhDs picking grapes on this particular afternoon. Anyway, I folded it up a little bit and looked on the internet, and there was a Pinot he puts out every year, and it had some pretty good write-ups. So I started chasing that about 10 years ago, 9 years ago, and as soon as I got onto the website, every year, after getting onto his email list that it's coming out, sold out. He only has a few. But anyway, last year it came out, you could get 2 bottles. Went on straight away, sold out. This year I managed to get some. But my internet was such that it folded halfway through the transaction. So I just went on and booked again. And then I started getting emails from his winery. Your order is incomplete, but I had a receipt number. But I did it right to him and said, "Dear Brian, we'd love to have a second lot, because you only allow you to get 1 lot, because I'm hopeful of putting one of these bottles down at least to celebrate the finish of the GMT. But I don't think the GMT or I will last that long. Or, sorry, your wine or I will last that long. But I have heard that it's going to be finished in the next few months, surprising enough. But anyway, I got a message back from Brian. I'm also working on the GMT, the Giant Magellan Telescope. Anyway, look, I'll leave these out the front, just don't lick the stamps. But there's a medallion there that's about $35. I managed to get them at the Dandenong post office today, but a couple of my friends couldn't get the medallion. The post offices, one was Hampton, I think, too small, but they did both manage to get stamps in the little pack. There was a group of 3 stamps inside, but it's featuring the GMT, the Melbourne Observatory and the Sydney Observatory. But I'll leave them out there if anyone's looking.
Thanks, Ian. All right, we'll jump into the talk that Duane gave here back in August 2025, and with that, thanks Chris for organising that. It goes with the questions at the end. It goes for about an hour and a half, which will take us to around about 10 o'clock. So if you need a cup of tea in the meantime or a bathroom break, feel free to get up and quietly move out. Duane is Associate Professor and Director of the Cultural and Indigenous Astronomy Program at the School of Physics at the University of Melbourne. His work examines humanity's connection to the stars and our presence in space in terms of science, history, culture and society, with a focus on Australian Indigenous astronomy. He's published over 60 papers and chapters, as well as the best-selling book, The First Astronomers, which you see up on the screen there. Duane has degrees in physics, his Bachelor of Science, Astronomy, Master of Science and Indigenous Studies for his PhD. With experience in archaeology, ethnography, geophysics and observational astrophysics. He was a recipient of an ARC DECRA Fellowship in 2014-18, where he worked for Merriam Elders to record and safeguard the astronomical knowledge and traditions of the Eastern Torres Strait Islanders. He was a Kappas Fellow in the Kate Hamburger Centre for Apocalyptic and Post-Apocalyptic Studies, which is a very, very impressive and worrying title, at the University of Heidelberg in Germany in 2022-23, studying cosmic phenomenon and the end of the world. He holds honorary positions in Australia, Germany, France and Honduras. Duane presented at TEDx in at the Northern Sydney Institute in 2013, appeared in the National Geographic documentary The Story of God with Morgan Freeman in 2016. The Warwick Thornton film We Don't Need a Map from 2017. Consulted on the Werner Herzog Clive Oppenheimer film Fireball, Visitors from Darker Worlds in 2020. And was featured in the University of New South Wales photography exhibition Wild Researchers from 2015. He's a science communicator, needless to say, a regular contributor to The Conversation and Cosmos magazine, and works as a consultant and curator for theatre productions, art and museum exhibitions, commemorative coins, tourism and education programs, planetarium shows, films, urban design policy and public outreach. Duane's service includes working as a heritage expert for UNESCO, an expert panellist for the, I'm going to get this wrong, Nanga project, president and founder of the Australian Association for Astronomy in Culture, vice president and president-elect of the International Society for Archaeoastronomy and Astronomy in Culture, former chair of the International Astronomical Union Working Group on Intangible Heritage, and is a member of the IAU Working Group for Star Names. He's an editorial board member for the Journal of Skyscape Archaeology, the Cultural and Historical Astronomy series of Springer Press, and served as associate editor of the Journal of Astronomical History and Heritage for 8 years. All right, so with that, can I get you to welcome Duane to give us his talk?
Thank you so much. I didn't expect you're going to read off my entire CV, but it's awesome. Thanks so much, everybody, for coming out tonight, and thanks to the Mornington Astronomical Society for inviting me to come out and speak tonight. I've never been here. It's my first time down here on this part of the peninsula. I kind of always drive through to get down to the hot springs or something like that, so it's great to come here and see it. It's a beautiful spot here. It's great to be on Boonwurrung country. I live on Boonwurrung country in Yarraville, but it's great to come out to this side of it over here. Such a gorgeous place. I'm really excited that we're working with Boonwurrung communities, Wurundjeri, Taungurung, Dja Dja Wurrung, on some major initiatives on astronomy and how we can apply that knowledge to skyscape tourism, astrotourism, how we can apply it to seasonal calendar development, education programs, a whole range of things, as guided and dictated by the communities. So it's great to be here on traditional lands of the Boonwurrung people, and I thank everybody for the invitation and for the community. If any Boonwurrung people are here or any local mob are here, thank you so much. I'm really happy to be here, and I want to pay my respects. You know, I moved here from the U.S. 20 years ago to study, I came to study astrophysics. But when I was here, I got very interested in the idea of Indigenous astronomy. And whenever I would ask people about that, I would get very dismissive comments on that. And it was a really frustrating situation because the idea that Aboriginal people have these complex systems of knowledge about the stars was something that just wasn't recognized. So I decided, well, you know, this is something that interests me far more than astrophysics. Searching for planets around distant stars is what I was doing for a PhD. And I left that world and I came to do a PhD looking at the science behind Aboriginal astronomy. And that's what I've been doing for almost 20 years now, 17 years. And over that process, I've been very fortunate to work with a lot of elders, work for a lot of elders, and a lot of community members all around Australia, all around the world, in particular in the Torres Strait. And I've learned a lot from that experience. And what I want to do today is talk to you and share some of what I've learned from the elders and the communities about the deep layers of science that are embedded in these knowledges. Now, when I say that, I want to be careful about that because that gives the implication that these systems of knowledge are only important or valid if they've got lots of science behind them. And that's not the case. They're valid in their own right. They're rich, deep, ancient systems of knowledge that are incredibly complex, and there's a lot we can learn from that. There also happens to be a tremendous amount of scientific knowledge that's been developed by Aboriginal people over millennia, that have been encoded in these knowledges, that Westerners have a lot that we can learn from if we stop and we pay attention and we listen. So that's kind of what I want to focus on today. And this ties in with the name of the book. So the name of the book that I wrote almost 3 years ago now is called The First Astronomers. And it's about the astronomy itself. Astronomy is a science. It's the science of the cosmos, of understanding the stars. And this is something that's, you know, the cover of this book is an artwork by Uncle Cigar Passy. He is one of the senior Merriam elders on Mare in the Torres Strait. If you're not sure where Mare is, it's in the far east of the Torres Strait, but most of you would have heard about Mabo. Koiki Mabo, Mabo Day, native title, all of that came out of the Torres Strait. And their systems of knowledge are living and thriving, as are many of them all across Australia. These aren't ancient things relegated to the distant past you see in a museum. This is living, thriving systems of knowledge that are ongoing today. But the thing I wanted to point out about the cover of this is it's at sunset. Part of that was I needed a great image for the book, and Uncle Cigar and I spoke about this, and we both have a love for sunsets. But it was more about understanding the context. It's not just when the stars come out. It's before the sun sets. Where does the sun set? What does it look like? How long is it in the sky? All these factors are important for understanding the context of how we can connect to the stars. Now, I wanted to talk about a couple of major themes before we dive into some of the fun examples of Aboriginal astronomy. On the left here is an image of Professor Annette Lee. Annette Lee is a Lakota woman from Minnesota in the US. She's an astrophysicist and a professional artist. She has 8 degrees, more than half my department combined, it seems. One thing that she's also the director of Native Sky Watchers, which is a fantastic education art initiative about traditional astronomy. And her communities are Lakota, Dakota, and Ojibwe. Something she talks about, which all elders anywhere that I've worked for or with talk about the same thing. Everything on the land is reflected in the sky. As is above, so is below. Well, what does that mean? Sounds very airy-fairy, right? Well, all it means is if you want to understand how things work here on the land, you need to look up to the stars. The stars tell us how to find our way across space, how to measure time, how to map out the landscape, which can be mapped out in the stars, and we're going to talk about that a little bit later. It's about how we connect to the stars, how we can denote seasonal changes, weather patterns we can look for in the stars, the behavior of plants and animals. That's all marked out by the stars. But the stars also serve as a memory space. How do we remember so much knowledge when we don't have these damn things, right? How do we do that? We look to the stars. The stars serve as a memory space. They serve as a map. And if you know how to read that, that is how you're going to make sense of it. The middle is Professor Martin Nakata. He's a Torres Strait Islander. He's the first Islander to earn a PhD in Australia, and he was the one who offered me my very first job when I finished my PhD. And we sat down in the room of Nuragili at the University of New South Wales, and we planned out the next decade of work on Indigenous astronomy. That's why he hired me, to build up all the work that we're doing now. Part of that was this book. But he said something to me back then. He says, we're a people of culture. Everybody understands that. Everybody recognizes that. But we're also a people of science. And that's something the public doesn't acknowledge, something the public doesn't recognize. And I want you, with your background in astrophysics, to help showcase the science behind these knowledges. I don't need to convince you it exists. You've done your PhD. You know this happens. But we need the world to know this. And unfortunately, for a lot of terrible reasons, people don't listen to Aboriginal people, and it's so frustrating. But we should be. This is something that elders have been saying for a long time. When I've go to communities by invitation, sometimes I'll meet somebody there and they'll be like, oh yeah, so what are you actually working on? I'm like, I'm showcasing the science behind this knowledge. That there's science here. The elders are like, we've been saying that for decades, but nobody will listen to us. It's like, well, now it's time to put this out in the world so people understand what this really means. And on the far right, there is Uncle Alo Tapim. Uncle Alo is one of the elders on Mare. And he, as with basically every other elder that I've ever worked for, says the same thing. Just like everything on the land is reflected in the sky, he says your ability to thrive and survive in your environment depends on your ability to read your environment. In this context, your ability to read the stars. Reading the stars means that you're able to observe and interpret all the changing positions and the properties of celestial objects and know what that's going to tell you. So we have a group of astronomy enthusiasts here. What are the properties of stars you think we're talking about? Positions of stars, right? When they rise or set at dusk or dawn is a prominent one. What else? Okay, there's constellations there, how they move across the sky. What about properties of stars? What are things we notice about them when we look up? Colors of stars, what else? Brightness of stars, good. What about changes in those? Changing colors of stars, changing brightness of stars. Those things can tell you something if you know how to read and interpret them. So how is this science embedded in Indigenous knowledge? Science is just one component of it. And I think it's important to understand that science itself is about understanding the world around us. We do that through observation, through experimentation, through inductive and deductive reasoning. We try to figure out how things work around us, how they started, how they work, and what's going to happen in the future. There's always a predictive purpose for that. Science is something that is a human endeavor. It's something that we all do in our different ways. It's like art. It's like music. We do it. We all practice science. But how is it encoded? Well, one thing I want to do is help dispel some misinterpretations. And this is the most important thing I think I could talk about tonight before I go into all the fun examples of astronomy, is getting over the idea that there is myth and fact. Myth and fact are not opposites of each other. They're not even in the same game. Myth refers to spoken story. Mythology is a study of spoken stories. It's spoken. For many years, I railed against the very use of the term myth. Don't call it myth. That word should never pass your lips, because there's a false dichotomy today that something is true or it's myth, which means it's false, right? But that's not what myth is about or how myth works. Mythology is a mnemonic. What do I mean by that? When you want to pass knowledge on to future generations, right now we tend to use these, right? We write things down, we put them in books, we put them on websites. Yes, somebody will stand up and, rant and rave and talk for a while, but we focus on the written word. But for a majority of human history, I don't mean history in the written context, but since humans have been around, we have passed things on through oral tradition. We pass things on through music. We pass knowledge on through dance. We pass knowledge on through art. Well, how do you do that? Well, you've got all this information you've got to pass on. How does the world around us work? How do we interact with each other? What are the rules? What are the lessons? How do you pass that on? You create narratives. You create stories. All of us relate to stories. We all love stories. If you do science communication, the first thing they tell you is you need to tell a story. When I wrote my book, there had to be a story. There always has to be a narrative, because our brains evolved in such a way as to develop the need for storytelling. That's a way we remember stuff. So you develop stories, but stories can't be boring. They have to be interesting, right? So as the old joke I used with old friends when we were younger trying to think of movie titles, it's ninjas, explosions, and dinosaurs, gods, monsters, and UFOs, right? It's stuff outside the normal day-to-day experience that's going to be memorable. We don't really remember the stuff we did a few weeks ago on a Tuesday or Wednesday, right? It's the weekend stuff that becomes memorable. Well, maybe we're all a bit younger, right? It's the sex, drugs, and rock and roll kind of stuff. And narratives, mythologies are filled with that kind of stuff because it's memorable. That's the reason. So what I want to get at before we dive into this is myth is a mnemonic. It's not separate from science. And it has to tell you things that are pragmatic. So one of the old Warrain elders said, our old elders, they were pragmatical buggers. We wouldn't have survived if they weren't. The idea that mythologies, if we think about that as being something fake and not true, then the knowledge encoded within that wouldn't have any practical application, right? And we don't think about that much today because we rely on these for everything, right? We don't look to the stars to predict the weather. We don't look to the stars to see what time of the day it is. If the sun's high or it's going down or it's coming up, that's about all we know. We don't need that. Anything we know, we just Google. When you don't have Google, you look to the sky, you look to the world around you. And if you get it wrong, nowadays, so what, right? I'm not planting my crops. I mean, you know, I'm not a farmer. I don't got to worry about that. But if your survival depends on that and you get it wrong, the whole community can die. That's why this is so important. So I know that in the past, the idea that we teach these cultural forms, these cultural knowledges of science, indigenous science, and it's been levied on me, oh, you're teaching myth is science. Teaching myth is science makes no sense. It's like saying, I'm going to teach a book as science. Is a book science? It can contain science. These books do, right? A lot of books don't. It's a technique. It's a method for passing on knowledge. That's what mythology is. So it's not the opposite of science. It's not the opposite of fact. It can have both fact and science embedded within it. So we're going to start to unpack this. So some things I wanted to talk about today. I didn't want to keep talking about the same stuff I ramble on about forever. I wanted to talk about some exciting things. Now, some stuff came out during my time working with the elders. And one of those things that comes out is that rare transient phenomena that don't occur very often, that might be fleeting, short in time, are well known and well understood. An example of this would be eclipses. So lots of different Aboriginal cultures across the country and cultures around the world understand the dynamics of eclipses, and they're described in a particular way. They'll describe, you know, the moon and the sun are usually spouses. Sometimes the woman's the sun, the man's the moon. Sometimes it's flipped around. With most Aboriginal communities in Australia, not all, but most, the sun's a woman, the moon's a man. So up in Gomeroi, UoM country, Uncle Gillar and Michael Anderson talks about Balu and Yai. Balu being the moon man, Yai being the sun woman. And basically, they're of the wrong marriage classes to marry, but they go off in secret and they become husband and wife together, right? And that's what we see as an eclipse. And there's lots of traditions talking about the sun and the moon being lovers coming together in an embrace during that time. Now, for those of you who already know how eclipses work, like, yeah, so what? We already know how eclipses work. Well, you know that because somebody taught you, right? But if you're out looking at this stuff yourself, you got to figure some things out, and you realize something. What time of the lunar cycle do total solar eclipses happen? New moon. Can you see the new moon? No, but you know the moon is there. How do you know the moon is there when you can't see it? Because you're observing its pattern, you're observing its behaviors. When you can see it, what it looks like, and when you can't see it. You know where something is going to be even when you can't see it. Now, this might seem like a silly thing, but it's something in the history of science is not given the credit for different cultures understanding this that it should. Now, a total solar eclipse only occurs from any given location once every few hundred years from any given place, and will never last for more than about 7.5 minutes, usually half that or less. Fleeting, quick events, but they are well known and described all around the country and around the world. And the knowledge about them is quite deep. Now, about 2 years ago, Nick Loam and Toner Stevenson wrote a book called Eclipse Chasers. Do you have a copy of that here by chance? Maybe? Grab a copy of that book. The second chapter is on eclipses in Indigenous traditions. And Uncle Gillar shares a whole load of information from UoM Gomeroi traditions about that that's never been shared before. There's brand new stuff about eclipses in there and what it means. But I want to draw your attention to something similar but different. In the Torres Strait, there's a special ceremony. This ceremony takes place during a total lunar eclipse. In traditional Torres Strait culture, I'll pull that back. In traditional Torres Strait culture, there are special people who are trained in the art and the science of star knowledge. They're called the Zugubal Mabaig. Zugubals refer to these spiritual beings, the Zogoli, who ascended into the stars to become the stars themselves. They are the constellations. So in the Torres Strait, when you see it referred to the Zugabal, that means spiritual ancestors who are the constellations. Mabayag simply means person. So Zugabal Mabayag means star person or constellation person. When they reach a certain age, usually early teens, they're taken from their families and placed in the quad, a sacred, secret place of higher learning, much like a university. They go through 7 years of intense instruction before their first levels of initiation, where they graduate. They're initiated as astronomers. And they continue their training throughout their life. They inform their buai, or their kinship groups, about everything that's happening in the sky. So islanders are a seafaring people. They're going out to sea for fishing, for hunting, but they're also planting crops, traversing to other islands. There's a lot you have to understand about the moon, the tides, the sun, the stars, the animals. The cosmos become an essential textbook that you need to learn how to read. Now, one of the top levels of initiation for the Zugabal Mabayag, when they reach the very top levels, I don't know what you might consider this, your promotion to full professor, something like that, they go through this special ceremony, and it's this situation where this total eclipse of the moon occurs. The community gets together, because this is also where there's a headhunting raid, and the elders talk about how this was very open in traditional times, where there would be a raiders attacking from an island to take the head of an enemy, because in that culture, taking the head of an enemy means you absorb all of their life energy. This is something you see in cultures around the world. The ancient Celts did this. They would hunt, headhunt and actually tie heads to their waist. We've all seen there can be only one. You take their head off. Remember Highlander, all that kind of stuff. These kinds of traditions are global. But the thing about this ceremony is this ceremony was only performed during the lunar eclipse, but it required advanced preparation. And when the elder was explaining how this happened, I remember asking him, I was like, it seems to me this isn't something you just start frantically doing when the moon goes into an eclipse. He says, no. It sounds like this was prepared. He says it takes months of advanced preparation. The Zugabal Mabayag, this is their top level of initiation to tell us when this is going to happen. Oral-based cultures predicting lunar eclipses. Do you see that in the history of science? You don't. The assumption is you need a written language because you have to have these long-term records to be able to understand that. And when I published this, people told me, oh, you're making stuff up. Yeah, I just make stuff up. That's how academia works, right? University gives me a salary, I just make stuff up. But what does it mean? It means that cultures have ways of passing down accurate, detailed bodies of knowledge and information over long periods of time that aren't going to degrade, that can be done orally. There's lots of ways it can be done. You can look at the Inca. They have the quipu, tying beads and knots and things. This ties in with the idea of method of loci, associating memory to place, which is something that all of us can do. It's learning how to associate memory to a place. A place can be an object. It can be the landscape. It can be the stars. But this is the top level of initiation for those communities. Now, how many of you think you could predict a lunar eclipse? Anybody? There's a few things we need to know. What time of the month, what phase of the moon do we have to be in for a lunar eclipse to occur? A lunar eclipse has to be a full moon, right? So you count the months. You don't have to count days in particular, but you count months, right? How many months before this will occur? What else do you need to know? Some of the people in the room who might know a little bit more about this. There's a couple times a year that this is going to occur. This particular situation can occur. Sorry? When it's lined up. You need to have the eclipse seasons where the equatorial plane and the ecliptic plane match up to where you have the potential of having syzygy, which is a great Scrabble word for those of you who don't know it. S-Y-G-I-Y, right? You need 3 Y's in that. It's in a perfect alignment of 3 bodies. So you need eclipse seasons, right? But you also need to understand the Saros cycle, which is just over 18 years. 18 years, 10 to 12 days, and 8 hours. An easier way of thinking about it, if you're paying attention over long periods of time, is 223 lunar months. That's it. So, question for everybody in the room. Who knows the difference between a synodic cycle and a sidereal cycle? You're like, oh, God, we didn't come for a lecture. We came for a talk, right? A synodic cycle of the moon is the time it takes for it to go through all of its phases. The sidereal time is the time it takes the moon to come back to the same position with respect to the background stars. They're off by 2.2 days, right? So what that means is if you watch and you see a lunar eclipse occur, you're going to notice the background stars around it. Several years ago, I was at Mount Martha Observatory giving a talk, and or I was at a talk at Mount Martha Observatory. There was a full eclipse of the moon, total eclipse of the moon. And before that, somebody was giving a talk and was saying, what stuff are you going to see in the sky? And I remember just throwing something out there saying, the beehive cluster. This person got very stern with me. You can't see the beehive cluster. All right. I know you can, but whatever. We go out that evening, we're looking, and there's the moon, and people are like, what's that group of stars right there? And I'm kind of like, I don't know, what is that group of stars right there? It was the beehive cluster, right? So what that means is, when you know in 223 lunar months, you're going to come back around to that position. It's going to be 8 hours later, but you get the idea, right? So what I'm trying to get at with this is predicting eclipses is actually incredibly complicated. These cultures worked this out a long time ago and have never been given credit in the whole history of science for being able to do this. So much of what is credited to European astronomers in the last 200 years is discovering things were phenomena that were well known by indigenous cultures all around the world. Well, how do we know? How do you know I'm not just making this up, right? You've got artworks. You can go to the museums and you can see the stuff there. I mean, you got the people telling you, which is what you should be listening to. But you've also got these dari. These are special dari headdresses that were designed only to be worn during these eclipse ceremonies. There's all kinds of other ones, and many of them, they go back pre-colonization. This isn't some new information that's been fed to communities. It's something they figured out a long time ago. Different kinds of phenomena in the sky that I imagine many people would see. Does anybody know what these are right here? Anybody have any guess? Yeah, what's it? Say it out loud, come on. With confidence, tell me what it is.
They like to be with the morning star.
Yes, morning star poles, right. So Yolngu communities up in Arnhem Land have a special ceremony called the Banambir. Banambir is describing Venus when it's a morning star. But the ceremony takes place when Venus first appears as a morning star. There's these long poles with these different feathers on different levels on it. And then you'll see many of them have these white feathers hanging down from strings. And on top of all of them, you're going to see a big white tuft of feathers. That white tuft of feathers represents Venus as the morning star ascending up into the sky. And the ancient traditions talked about a woman whose name was Banambir, who was gradually brought up into the sky, but she was afraid of floating away, so her sisters tied a rope to her to keep her bound so she wouldn't float away. There's a couple of interesting things we're looking at here that are pretty cool. How many of you have seen this before? What are we looking at right here? Anybody know? Some of you know, you're terrified to say anything. Come on. I gave a talk to 6-year-olds a couple of weeks ago, and I love it, because 6-year-olds will answer a question whether they think it's right or not. It doesn't make any difference. Pure confidence. The undergrads I teach in my class are terrified of answering any question, afraid they're going to get it wrong. I don't care if you get it right or wrong. What do you think we're looking at here? Well, you can see the Pleiades in there, which you're not wrong. That's not what I'm getting at, but you're not wrong. So we're looking at Venus, but what else do you see there? The zodiacal light, right. The dust reflected, or the dust in the plane of the solar system that reflects sunlight, and we see as this sort of hazy band of light in the sky. So what we're looking at with those morning star poles, those feathers coming down that we see represents the white rope that tied Banambir to the horizon so she wouldn't float away. We can see that. Interestingly, in the Torres Strait, the elders sat down with me, one of them, and this is the first time I'd ever heard this. He starts talking to me about how later in the year, around November, you look just after sunset for a column. You'll see light in the sky, and he does this with his hands. He puts it like a triangle kind of shape. He says, you talk about this band of light that goes straight up to the top stars, he says, referring, to the zenith. This band of light like this that will signify that in a few weeks the monsoon rains are going to come. And he's telling me this, like I just said, and in my mind I'm thinking, oh my God, he's talking about zodiacal light. So when we got done, I went back and I pulled up Stellarium and I looked, and yes, after sunset, in late November, the ecliptic goes straight up to zenith, directly perpendicular to the horizon. And of course, zodiacal light's going to hug the zenith, of course. That was the first time I'd ever read anywhere about zodiacal light being used as a calendar, being used to mark time. And since then, I found a couple more references about that, which I thought were pretty cool. But this whole idea about Venus coming around as a morning star, well, what's so important about this? Why is this so interesting? Where's the science behind this? This requires us understanding the synodic period of Venus. So Venus goes from periods of being the morning star, disappearing, evening star, and coming back. This is how it works. Venus will be visible as a morning star for 263 days. It will then go behind the sun at superior conjunction, and it gets so close to the sun we can't see it. That occurs for about 50 days. Then it sort of reemerges in the morning. So we've got, a morning star, then it reemerges in the evening. Then it's up as an evening star for 263 days. Then it comes in between us and the sun, inferior conjunction. You're being quizzed on this, by the way, before you leave. You don't get dessert unless you get the quiz right. But because it's coming between us and the sun, it's going through relatively quickly. It only lasts for 8 days before it reemerges as a morning star. So we call this the synodic period of Venus, the time it takes for it to do that one loop as we see it from morning star back to morning star again. 584 days. It's actually 583 days, 0.94 or something like that. It's a very small change, but that means you have to observe Venus over long periods of time to notice this cycle, to be able to pay attention to when it's going to happen. Now this has been described by Aboriginal communities across Australia for a long time, not just in Arnhem Land, but all across Australia. And a long time ago, my old PhD advisor, he visited communities in Arnhem Land, and he sat with a very well-known elder, and he asked him a stupid question, as we all do as academics who don't know anything. How'd you know it was going to happen? And he's like, we count the days. How do you think? Right? Why does that matter? Well, I don't think it should matter. I think counting the days should be pretty obvious. But why it's important, and what are the main motivations for the work that I'm doing, and why I'm talking about the science in the first place, is that traditional knowledges in this country for so long have been degraded and infantilized and told there's nothing here. There's no science, there's no mathematics, when there is science and there is mathematics. I've met plenty of people who were told that when they were in school, they learned Aboriginal people couldn't count past 5, which is ridiculous. When you look at the number systems, what you find is many of them are base 5. English, right? 1 to 10, we use a base 10. Right? We count to 10, we count to 10 again, and we do everything by multiples of 10. Many Aboriginal languages were base 5, some were base 10, some were base 20. Right? So if you look at the way the words are combined to make things, it'll be like 2 and 3 is 5. Like there's 1, 2, 3, 4, 5, and then beyond that, there are different words that are combinations of those that are used to describe higher numbers. When the Haddon expedition went to the Torres Strait, they wrote in their notebooks, the community seemed to have words for numbers referring to hundreds and to thousands. But that can't be right, so they must just mean a lot and a whole lot. Sort of discrediting the idea they would have advanced numerical systems. Well, you talk about predicting eclipses, right? You need to have words for that. I mean, this seems so basic, but it's something that just is not recognized. And it's this prevailing misunderstanding and misinterpretation in society. So let's talk about something a little bit different. I don't want to talk about how modern science matches up with indigenous knowledges, but how can indigenous knowledges inform and guide modern Western science? What are some ways this can happen? Well, what are we looking at here on the image? Right? What did we see last year? Lots of, especially down this way. Right? Well, you guys did. I didn't see anything. That day that the aurora was really popping off, I was up in northern New South Wales, and it was bucketing down rain. I had a PhD student who was visiting from Brazil. He was in the middle of St. Kilda, and he says the sky was lit up completely. You could see pink, and you see everything. He's just standing there looking at it, and all the light pollution and everything was that bright. And I'm on my phone yelling expletives because I'm up in the rain in northern New South Wales. Well, what are we talking about here? One thing I find interesting, we look for cycles in nature. We measure a day by the time it takes for the sun to appear to rise in the east and set in the west, right? And come back around. We consider that a day. How do we measure a month? We look at the moon go through its phases. How do we measure a year? Well, the stars will come back to the same position at the same time of the day in a year. Or the sun will go from solstice to solstice or equinox to equinox. We can measure out the year that way. We can put those things together. We can try to figure out how many times the moon goes through its phases in a year. We can try to link that together. We have to add things in to correct it, and it all gets very complicated. But there are cycles that go beyond that. I mentioned Venus' cycle of 584 days. What I didn't forget to mention, because there's so much I want to talk about, but I don't want to keep you here all night. With Venus, Venus does something very peculiar. When you look at Venus' position at the same time of night, when it's either a morning star or an evening star, and a fun trivia fact, what you call Venus when it's visible in the sky during a morning or evening is apparition. Who knew that before? All right, so you see Venus, that period of time, that 263 days, it's there as a morning star or an evening star, that's called an apparition, like a ghost. If you were to plot the position of Venus, it traces out 5 distinct patterns. Each one of those patterns repeats every 8 years. Why? Because Venus and the Earth are in 5/8 resonance. For every time the Earth goes around the Sun, Venus goes around 8 times, because it's closer to the Sun than we are. Right? Which means these 5 distinct patterns are going to repeat every 8 years. So you cannot separate space and time. We talk about that in modern physics. We talk about that in Indigenous astronomy. Space and time are part of the same fabric. So it's not just knowing when Venus is going to appear as a morning star, it's where is it going to appear. So you have to understand this. Now, something I taught in my class this week, which I thought was kind of interesting. Who's got to get your phone out, get the calculator app on your phone out now, right now, get your calculator, and do the ratio of 5 to 8. How many times will 5 fit into 8? A couple more decimal places, but about 1.6, right? The closer approximation to this resonance is actually 813. For every 13 times Venus goes around the Sun, the Earth goes around 8 times. What's the ratio? How many times will 8 go into 11? Or sorry, 8 go into 13? 1.625. 1.625. Okay. 1.625, 1.6. What does that sound like to you? There's a special number in there. Yeah?
Golden ratio.
What's the golden ratio number?
1.618.
Right. Okay, let's look at something else. Okay? I talked about 5, 8's resonance, 8's 13. Okay, 1, 1, 3, 5, 8, 13. Fibonacci sequence, right? This is the whole foundation of the harmony of the spheres concept in the history of astronomy, right? And you find, anyway, just fun little trivia facts for you to know. Getting back to this, we look for cycles in nature, and they go beyond a year. They'll go beyond a day or a month. They can be longer term. The cycle of Venus, 584 days. Well, the Darawal people of southern Sydney talk about the Mudong cycle. The Mudong cycle is this 10 to 11 year cycle where there's different changes and shifts in climate. But it's kicked off by noting the appearance of the southern lights in the south and towards the southwest. But not just the appearance of the southern lights at that time, but the fact that they tend to occur around the end of September and into October, and sometimes end of March into April. Now this is something that was not recognized by Western science until 1977, or at least not explained in any sort of detail. Anybody ever heard of the Russell-McFerrin effect? There were two geophysicists named Russell and McFerrin, right, who published a paper explaining why it is that aurora tend to be more frequent, more intense around a certain time of the year. This time of the year is when the equatorial plane of the Earth and the ecliptic plane cross over. What happens at those points? Astronomy folks? Sorry?
Equinox.
Equinox, right? Halfway between solstices. That's when they cross over. What happens is the interplanetary magnetic field from the sun, which goes out towards the Earth has its own magnetic field, which moves all those particles away from us. Some of them get in towards the poles, and then we have these big rings around the poles called the auroral zones, where those charged particles come in, they're ionized, they interact with the particles in our upper atmosphere. When they do that, they ionize, they jump energy states, they release energy in the form of light, and we see that light as aurora, right? We all learned a bit of physics tonight. But what happens is when these two are perfectly aligned, normally they're not, but when these two are perfectly aligned, they kind of cancel each other out a little bit. They weaken each other, allowing more of those sun's particles to come in, getting more intense aurora and more frequent aurora. Something that was kind of known, described in various ways by Aboriginal cultures, but wasn't really described in modern Western science until 1977. Which is kind of cool, but that's not the example I wanted to give tonight. So aurora are very well-known phenomena across Australia, particularly down here in the southern part of Victoria, South Australia out to Perth, and in particular, Lutruwita or Tasmania, but are known far north as well. There are cultures, the Pitjantjatjara in Uluru, Ngurrngu people up there talk about how aurora are seen as spirit ancestors. They're known in southwest Queensland. So last year when we had all those aurora going off, you could see them from Townsville, right? One of the reasons that's happening is the magnetic pole of the Earth is moving rather quickly towards Australia. It's actually between Australia and Antarctica. It's not no longer over Antarctica, it's actually over the Southern Ocean there, which means that auroral zone is being tilted up towards Australia, which is why we see so many, but in Africa you don't. Right? But what's interesting about this, here's something that was described. There was a splendid aurora, grand in its effects, at Hobart Town on the 4th of September, 1851, where the vividly shooting streamers of violet, red, and other colors were somewhat marred by the bright moonlight. The Aboriginal people compared the crackling noise of the conflagration to the snapping of their fingers. They're talking about Aboriginal people saying the aurora makes sound. Has anybody ever heard an aurora before? It sounds kind of absurd. Wait, what do you mean, aurora making sound? How does light make sound? And you start looking into this, and you find examples all across the country of Aboriginal people talking about how aurora would make this crackling, hissing, popping sound like static or rustling grass, like radio static you hear. What does this mean? Well, you start looking into it. You go to the Northern Hemisphere, and you find out the Northern Diné, Inuit cultures in far north of America. Lots and lots of traditions about the sounds aurora make. You look at the Evenki people in Siberia. They talk about sounds aurora make. You go to the Sami people of northern Scandinavia. The Sami word for aurora actually means the light you can hear. What in the world is going on? How do you hear light? And you find out cultures all around the world who experience aurora on a fairly regular basis describe this phenomena. Western science says, rubbish, light doesn't make sound, this is just a bunch of myths and legends. You know, people hearing things, they're hearing something else, it's not related to aurora. Dismissal, denial, rejection of the traditional knowledge. And yet, about almost 20 years ago now, there were a group of Finnish people, group of colleagues One of them was Untu Lane, the solar physicist. They were up at a jazz festival in northern Finland. And when it finished, they decided to go outside. The aurora was going off. It had snowed, and it was minus 35 degrees outside. Brave souls for doing that. You wouldn't catch me doing that. And they were sitting outside. They'd been inside listening to music, and they came outside to listen to silence, right? The snow really creates a silence. It dampens the sound. And they were kind of curious. There was no wind. Everybody was asleep. They wanted to go outside and try to experience real quiet. It's like going into a cave to experience true darkness. They wanted to go outside to experience true quiet. And the aurora were going off, and they started hearing stuff, this crackling, hissing sound. And they noticed that it seemed to be synchronizing with the movements of the aurora. And they were talking to themselves saying, like, do you hear that? Is that related to the aurora? And they were like, no, no way. That can't be it. But it got them interested. And Unto Lane decided to pursue that. I don't know his personal details. I don't know exactly what motivated him beyond that. I don't know if he ever asked the question, do the people living in that community have words for the aurora that mean the light you can hear? I don't know. But he became obsessed with this. Well, I don't know if he'd say he was obsessed, but he became interested in this topic. He decided to run a bunch of experiments, and over the next few years found the physical mechanism by which this can actually occur. It's this weird, we're not going to go into the deep physics of it, but it's this weird temperature inversion where the temperature gets higher as you go higher up in the atmosphere. Normally it's the opposite way, right? You go higher up, it's colder. When aurora are working this way, you get this change in the layers of hot and cold air that are trapped, which creates this boundary. But the hot rising air carries the negative charges from the ground up top, and the auroras increase the conductivity of the atmosphere, causing the positive charges to flow down. And basically what happens is like rubbing your feet across a carpet and touching something metal. What happens? Zzz. It's kind of like that. But that happens in the air and causes this discharge sound. And that's what causes aurora to make sound. This is not something that was known in Western science until the last decade or so. But it had been described by people, by Aboriginal and Northern Dene communities, Inuit and Venki and Sami and communities all around the world for a long time, centuries, maybe thousands of years, been talking about this. But Western science never listened, because how could these indigenous people know anything about science? Well, because scientists need to pull their head out of their collective backsides and start to listen. Has anybody ever heard this before? No? Let's see what it sounds like. See if this will play for me. Oh, I'm not hooked up to the internet. That's all right. What I want you to do, yeah, I know. Go online and look up sound of aurora, and you'll be amazed at what it sounds like. It's really awesome. The last thing I want to talk about are star maps. So we know that cultures around the world use the stars for navigation and wayfinding. How do you make your way across land and sea? And there's two general ways of doing that. One is to understand where your local environment is. You need to know where your directions are, north, south, east, west. You can use the stars for that. Everybody knows how to find south, right? What do we use to find south here? Southern Cross, right? We can use the Southern Cross by itself. We can look at the top and bottom star, Alpha Crucis and Gamma Crucis, and measure about 4 times that to get to the South Celestial Pole. Then we go straight down. We know the angle between the pole and the ground is our latitude, right? So we can get some information from that. Maybe we triangulate it using the pointer stars. Maybe we use the Magellanic Clouds as sort of a triangle. There's lots of ways of doing that. But you can find your position. But as with a lot of oceanic cultures, Polynesian cultures, Melanesian, Micronesian, all around the world, you would follow a star, know its azimuth, its direction along the landscape or along the horizon, and follow that star to get from point A to point B, right? Second star to the right, straight on until morning. We all know that one, right? Another way of doing it is extremely different. It's not following the stars, but mapping the stars as a reflection of the land to memory. The way this works is, this works the same in navigation. If you're on an island and you don't know where everything else is, you can't use the stars to tell you how to get to a place if you don't know where that place is already? Right? It tells you how to get from point A to point B. If you know the route between them, you can figure out which stars to use. So with the landscape, it's similar. We're going to travel from point A to point B, which might be several hundred kilometers. We've got to figure out the best route to get there. We're not going to walk over mountain ranges. We're not going to walk through swamps. But it's going to take weeks. We need to know where to camp, where to walk, where the landmarks are going to be, how we can find our way across. Once you figure out that route, you've then got to teach younger generations. How do you do that? You tell the stories, but you embed that within a song line or a memory map. You can use the stars for that. You say, well, we know the rough pattern we have to go in the landscape, how long it takes to get there, what things to look for in the landscape. You take a turn at the river here, where there's a mountain there, there's a big rock there. It gets far more complicated than that. I'm oversimplifying it. But you need to tell the younger generations, well, you look at stars that have that same general orientation. Yes, I know. That's my timer. Telling me to wrap it up soon. You look at the stars and you use the stars as a map where they count as the waypoints on your journey. So you can actually map them out in the stars. So you do that, and then you teach the younger generations earlier in the year, at night when stars are out, you teach them this map. Later in the year, when they travel, they're not traveling at night. They're traveling during the day. But they're traveling based on the memory. They've memorized the route based on those stars, and they know the song lines that can take them across land. So here's an example of one song line that starts in the town of Gaduga in northern New South Wales, almost to the Queensland border. And it goes up, and you see how they talk about, UoM will talk about these stars being the waypoints in your journey where you want to camp out. This goes from Gaduga up to Carnarvon Gorge. Now something interesting has happened over time. As people have traveled these these song lines going across land, when the colonists came to Australia and began expanding across the country, in many cases, the colonists would follow the same routes that Aboriginal people took. They would camp at the same places, which were usually water holes along rivers where you had a water source, where you had food, you had game, you had medicine. In many cases, Aboriginal people these new people come in, they would show them how to get from point A to point B. So over time, those pathways that you would walk became roads. And where you settled and camped out became settlements, villages, towns, and regional cities. What this means is today, if you look at these star maps and you scale them out and you lay them over top of Google Earth, we can see something interesting. What do those yellow lines on that map represent? They're roads and highways, right? And what are those stars representing? Towns and regional cities. Our highway network around Australia and many of the towns are reflected in Aboriginal star maps. These are the origins of them. And there are a great many of them that go all the way across the country. So there's some that start at Gaduga, but they go out to the Bunya Mountains for the Bunya Nut ceremony and festivals. And those corner at Theta Scorpii and go further out towards the Bunya Mountains. There's different stars that represent those waypoints in the journey. We can see our modern highway network is reflected as star maps in the sky. Well, let's go to WA. Let's go over there. We can see these are a series of sacred Aboriginal sites where there would be travel between them throughout the course of a year. This is knowledge shared by Uncle Noel Nannup, Dr. Noel Nannup, a Noongar elder. And these are reflected as some of the pathways of the brightest stars in the sky. Look at that shape. Look at the map we just told you about. Now remember those three themes I was telling you about at the very beginning of this talk? What was the very first one? As above, so below. The land is a reflection of the sky. The sky is a reflection of the land. You can see that as a perfect example here with these star maps. So we can see how celestial navigation not only ties in with the positions of stars, And in many cases, constellations. Long linear constellations were often used by Aboriginal cultures and Islander cultures to navigate, because as they moved across the course of a night, they would radically change position. What do you think this is telling you? What are the two things you can't separate? Space and time, like hands on a watch, right? The elders talk about this when the stars move. The Milky Way, Scorpius, Hydra, these longer linear constellations, as they move across the sky, represent space and time. So we can see how that works with navigation, but we can also see how you can find your way across a landscape by memorizing routes and encoding them in the stars as star maps. So what I hope that we've been able to do tonight is learn a few things about some interesting aspects of astronomy, but what I want you to take away from this more than anything is an understanding that Aboriginal and Torres Strait Islander knowledges about the stars are incredibly complex. They're extremely ancient, haven't even had time to go into how old these things are, but they go back over 10,000 years or longer. That there's a lot we can learn, that we can learn from ancient Aboriginal knowledges. This is not something that sits in a museum. This is living, thriving knowledge, and it's something that we all need to learn about, something we all need to understand, and something that we all need to respect. But thanks for coming out, and if you want to learn more about this, you can see all the stuff I didn't get to talk about. And The First Astronomers is a book. It's paperback, it's an ebook, and it's an audio book narrated by Adam Sims. All the author royalties of the book go to a charity. So I don't make any money off the book, right? I'm not up buying a Mercedes off this, as if. But that goes in to help pay the elders for their time. It supports scholarship for young Aboriginal students coming into astronomy. It supports conference attendance. It supports all those kinds of research activities and things for Aboriginal and Islander students around Australia. And colleagues like Annette Lee and Rangi Matamua, who have Maori and Native American astronomy tied in with that, they get cuts of their author royalties as well out of this. So if you want to grab a copy of that, you can get that at most any bookshop or library. But I am happy to say that right now I'm writing my second book with Marcia Langton. If you've ever read Marcia Langton's book, Welcome to Country, we're doing a sister companion called Welcome to Sky Country. That should be out in about another year and a half. It's going to be more of a travelogue of sky knowledge around the country. It won't be the same stuff I have in this book. It's going to be a lot of new stuff in there. So you'll be able to check that out. All right. Thank you so much for your time.
Do we have any questions for Duane?
How long do you think, now with modernisation and integration of the white people, these stories going to keep passing down for? Is the information degrading now, with the introduction of...
There's still communities still sharing knowledge all the time.
They're not relying too much now on technology and this...
We all rely on technology. I think it's important to understand that any cultural tradition from any culture is going to evolve and change over time. No knowledge system is static. I mean, you think about it, it can't be. There's always going to be new technologies, new ways of knowing, meeting new people, new things. There's always going to be an evolution of that. There's always going to be a change of that.
So you don't think the skills of the oral passing down the messages are going to be...
I mean, there is a change in that's happening, and the elders are very open about this. So in the Torres Strait, for example, and this happens a lot of places, in the Torres Strait, most of the islands, if they have a school, it only goes to year 6. So on Mare, there's about 450 people on the island. The school they built on the island only goes to year 6. If you go beyond year 6, you go to Badu, Thursday Island, or the mainland. You stay with family or at a college or something like that there. And what that means is before that, elders are passing down knowledge. Not like every other kid, they're playing video games or on their phones like everybody is, right? And some of them aren't paying as much attention, Most of us didn't either. But especially when they reach that age of around, what's year 6, 12? 11, 12, something like that? Then they're off somewhere else for long periods of time. They only come back during holidays and school breaks. And then once they reach adulthood, there's little or no economic opportunity in the island. So coming back and living there isn't really much of an option. You just come back to visit. So there's a rupture and the transmission of knowledge is being passed down. And elders openly talk about this. I've sat down with elders in their 70s saying, oh, my parents told me a lot of this stuff, my grandparents told me, but I never paid much attention. I was too busy playing rugby. I really wish I'd paid more attention. And some do know it. So those kinds of things do happen. Some of it's economically driven, some of it's because of the situation with schools and having to travel and being other places. Some of it's with the, a big part of it is the general rejection by mainstream Australian society that you're not allowed to have your culture. You have to amalgamate into this culture, assimilate, and this is rubbish. But yeah, there are those problems, right? But that's why elders are like inviting me and building up these programs that we can help bring this back, because they'll say lots of different elders will have bits of knowledge, but there's nobody who knows all of this, and there's no repository we have for all the knowledge. And some of it's very secret, and some of it's got different restrictions on it. So we work with the community to identify this, to try to pull it together, to do some analysis, to build these seasonal calendars, and try to restructure elements that might have been fractured because of colonization. You're never going to get as complete a body of knowledge as you had before 1788, right? But you can do a lot of amazing work with that. So that's what's happening with a lot of communities right now.
Duane, do you mind if I just add to that a little?
Oh, please do.
Just from
a
learner perspective, you had Nakata up there, and Nakata's actually doing a lot of work in the education field that, a lot of Australians now are wanting to learn more about our First Nations cultures, and we're having things like 8-way pedagogy, 2-way learning, all of those things, which means that one day, hopefully, First Nations peoples won't be scared to keep their children home to do those oral learnings, because if they do, they might get removed at the moment and previously. But I think there's some improvement or steps forward there, especially with Marsha and Nakata and those sorts of people. Sorry,
Thank you very much. I'm Uncle John. I'm an Aboriginal elder of the Wadawurrung people of the Western Plains, and an elder at Willum Warrain Gathering Place here in Hastings. Just on behalf of my other Indigenous mates here, thank you very much. It was very enjoyable. Two of us here are culture tour guides as well, and we've picked up a bit of information. Thank you very much, because we do get asked by the older children that come to see us how we navigated, etc. My young lady here next to me is much more learned than I am. I'm just the old bugger. But I'd just like to say thank you very much for the invitation for us to be here. There were to be more of them, but there are other things happening. But sir, thank you very much. Very enjoyable, very interesting, and thank you again.
Well, thank you, Uncle. Appreciate it.
I was just curious if, say, people that live right at the top of Queensland and Tasmania, are their knowledge completely different, or do they sort of relate? Is it the same knowledge, or is it?
So what you're going to see when you're looking at different systems of knowledge, first off, communities connect to each other. Aboriginal communities are not in isolation, of course, right? There's networks that go all the way across the country and beyond the boundaries of Australia. So you're going to have that knowledge sharing and capacity. But the skies are going to be different up there. The weather's going to be different. The environment's going to be different. And something that Nakata, was great at teaching me, is Indigenous knowledges are developed in situ for that local environment. If you pick it up and try to plonk it somewhere else, it's going to have to change because it's a different environment. It's about that local area, how those plants and animals and seasons and geology, how all that works together. But the knowledge of all of that is based on biology, chemistry, physics. So it's going to apply around the world. So when you look at things I didn't talk about today, for example, the twinkling of stars, right? Stars twinkle because of turbulence in our atmosphere, wind, right? So no matter where you are in the world, you're going to know that if you see stars twinkling, that means there's wind movement. That might mean something slightly different where you are. If you're in the tropics, which are dominated by trade winds, that might mean the shifting trade winds are going to bring in the monsoon or the dry season. If you're down here, it's going to be different. But you're going to understand that twinkling means air is moving. And then if you know how to read that and the other parts of the landscape, like a ring around the moon, these insects are doing something weird, a storm's coming, for example. So you're going to find that all around the world. So you're going to find these similar themes all around the world, even though some of the elements might be a bit different. So yeah.
How many communities did you work with, and do you plan to work with any more to sort of gain a lot more of this knowledge?
In various capacities, probably about a dozen different communities I've worked with so far. I should say work for is how I tend to put it in. At the moment, we're working on building an overall Kulin Nations program, because I was invited by the Taunarong before COVID happened. They wanted to do something, and then the Jaja came in, and then Bunurong wanted to come in, and then COVID happened. And then by the time we got out of COVID, everybody in the land councils had disappeared, and new people were there, so we tried to get it going again, and nobody knew who I was. But we've got some projects going with the different communities. I'd love to talk with Wadarong as well about what we can do. And we've got Wurundjeri, Bunurong, Jaja, and Taunarong who've got different needs, because these research projects aren't driven by the needs of academics, they're driven by the needs of the community. Like, we can do this, what do you want to see? The different communities have different needs. So Jaja really want to do, astrotourism, for example, where some communities want to focus more on education. Others will have preserve the dark skies and use whatever means we can to help keep light pollution at bay. And some of them are going to cross over in different ways, right? You've got tourism programs you're doing on country, things like that, where maybe there's a star element you want to bring into it. That's why we're here to do our part to help. But it's going to vary between different communities. But we're got a team of graduate students of different cultures around the world. Some are, we've got an Aboriginal guy at ANU working on dark sky and satellite impacts of light pollution and how that ties into and impacts Indigenous astronomy. We've got students down here working on astrotourism and dark skies, students working with the communities of the Kulin Nation. So a wide range of students doing these projects in different areas to help train up the new generations. But it's driven by the needs of the community.
And in all your time studying these things, what has been the most surprising thing that you've discovered along the journey?
The most surprising one is how quickly the astrophysics community accepted this and took on the knowledge to adopt it into their practices. I honestly thought I was going to have the most uphill battle you can imagine, convincing the astrophysics community of all the amazing scientific knowledge here. And maybe it's because, I don't know, maybe because I just did a bunch of research, and generally astronomers, if you present the research, will say, okay. That doesn't always happen, right? In a weird twist, my expectations were that the astrophysics community and science community in general was going to be very skeptical of this, but that the social science community, the archaeologists, anthropologists, linguists would be like, yeah, we get that. And what I found in my experience was the opposite. There could be a lot of different reasons for that, but I found barriers and walls in the social sciences I didn't expect, and I found acceptance in the astrophysics community that I didn't expect either. Now, it's not quite that black and white, but I'm working in the physics department at the University of Melbourne. My full-time job is doing this. I never in a million years would have thought that was possible. I never thought a university would let me do this kind of stuff. And then the funniest thing, I'll give this as my last bit. A few years ago, I do this every year. I teach Indigenous Astronomy as a first-year course at the University of Melbourne. And about the middle of the semester, I bring in some elders and practitioners from around the world, some local elders, some practitioners from other parts of the world, to give some guest lectures. And the very first time I ran this, I had a local guy that I know named John Paul Eagleheart. He's a Shuswap shaman. Shuswap were First Nations community near Okanagan in Canada. And he trained for most of his life, he's in his 60s, he trained for most of his life under the counsel of 26 grandmothers to be a shaman, right? And he practiced all around the world. And he ran a place called Auspicious Arts in Melbourne, big to-do thing in the arts and theater industry. But he still does the shamanistic work. And what I wanted him to do is come in and teach the class about the medicine wheel ceremony and the astronomy embedded within that. But we spoke about what I didn't want him to do is what I'm doing. come in and give a lecture type of thing where you sit there and listen and I go and tell you about a different culture, right? Where you may not be of that culture, I'm not, and I'm going to talk about this culture. I said, no, I want you to lead them through it. He says, oh, we're going to have fun. I said, yes, we are. So I want you to picture this scenario. The School of Physics, David Carroll Building, University of Melbourne, kind of a big, giant building with a big wing that comes around, and in the middle is a courtyard area. I've got all the students in that semester, of which there were about 30, the first time I taught it. We're outside in that courtyard at noon on a weekday in a big circle with John Paul in full regalia passing around burning sage as the students stand up and pray to the seven winds. And as they're doing that, he's explaining the astronomy to them, right? Now, knowing the motivation behind it is something, yeah, that's what I was doing. You know, the students in the class knew what we were doing. Now imagine everybody else walking past, getting their lunch, grabbing their coffees, and walking by and seeing a shaman with a bunch of students in circles standing there turning and praying to the winds. We got the wildest looks. The senior academics smiled at me because they knew what I was doing. The junior ones were kind of like, what's going on? Some of the students thought it was hilarious, and I actually broke the circle to go in and chew some of them out royally because they thought it was, you know, it wasn't a, haha, this is cool. It was a, haha, look at this. You know, they're teaching astrology or something. And I went into the room and I tore into them, explained to them what we were doing. And then a couple of weeks later, I gave a colloquium for the School of Physics. Says, shamans or science, what the hell's happening in the School of Physics? Nobody had said a word to me, but I gave a seminar where I explained this, what we were doing, and how the students getting embedded, learning directly from a shaman, an elder, about the way that stuff works, on the land, in a multisensory environment, learning about how, the students said that was their favorite lecture the entire semester. They learned, they remembered everything they did in that lecture as opposed to me just and people falling asleep, right? They remembered all of that. They loved it. End of semester reviews, that was their favorite lecture. I've done that every year since then. Never have I had a peep from the School of Physics about that because they had to vote unanimously for me to be there and they're happy for this to happen. But there are still no Indigenous academics in the School of Physics, and that's something that we're there to help change. It's going to take time, but it will happen.
And people from a European heritage would immediately think of Stonehenge. Any equivalent in Australia?
There are stone arrangements which seem to mark out astronomical positions. They're around. Some of them are many places very secret. I've been to a few. Aboriginal cultures have the same kinds of astronomers that Torres Strait does, right? They're the old people who were taught the ways of the stars, who would sit on hilltops in circles. And I've been up one in Tonarong country where it was a circle of 24 stones, 4 larger stones about this high, 4 cardinal points intersected by 5 stones of each diameter about that wide, flat around that, in a circle on a ridgetop that was almost exactly 6 meters in diameter on a farmer's property. And they brought me up there, Liz, what is this? And I'm like, I don't know, but this is pretty damn cool. Right, but that's something that's known around Australia. That was a very common thing because if you're going to pay attention to the stars, you want to be someplace that's high where you can see everything, but you need some markers to help you understand and be able to measure positions of stars. They could be used for that. So yes, there's places around, but keeping in mind that a lot of places that stuff is fairly secret. Even though some of that may be in the public domain, that doesn't mean it's supposed to be in the public domain. I mean, you can look back to, if anybody knows how many people know their history, you look at Nomads of the Australian Desert by Charles Mountford, perfect example of that. He was able to bear witness to secret pitch and jar ceremonies, and the elders said, well, it's very taboo for people outside, for people who aren't initiated to know this. You're an outsider, it's okay, but don't tell anybody else. He wrote a book about it. Right? So this kind of thing, just because it's in a book doesn't mean that it's okay. So yes, there's a lot of stuff out there, but there's a lot of sensitivities around that stuff as well. Right.
It's not so much an astronomy question, but in terms of how being so present to different knowledge systems and ways of learning through your research, has that impacted your research practice
Oh,
in
immensely.
any interesting ways?
Immensely, immensely. I've got my own background, my own biases. I came to this when I was doing my PhD in Indigenous Astronomy at Macquarie University. I co-founded a skeptic society, right? Which later was amalgamated with the Atheist League. But we were there, you know, and a big part of what we were doing was separating science from creationism. I grew up in Bible Belt, mid-Missouri in the U.S., right? In a small rural town, you know, with Assembly of God Bible thumpers everywhere. I knew about that world very intimately, right? That was something it was one of those areas I was railing against. But there became times when I became such there's a scientist and there's scientism, right? I became, so ingrained in that I could realize that I was conceptualizing things in the wrong way. And I was doing this work in Aboriginal astronomy, but then I would do that and I'm like, well, what's the real difference between them? It's a huge difference, but it took me a while to really understand what that really meant. But it led me on a path of knowing how to ask certain questions and what the meaning and context of them are. So I came in with my own biases, I came in with my own background, and that's changed radically over the years, but still in the process of changing now, right? So now when I teach archaeoastronomy, which I'm doing right now this semester, the student's first assessment is a positionality reflexivity statement. What I want them to do is talk about their background in terms of study, in terms of lived experience of their culture. When they come in to study cultures, in that case, in archaeoastronomy of the ancient past, what biases are they bringing into this? How is it going to benefit the work? How is it going to negatively impact the work? What are they doing? And there's lots of ways in archaeoastronomy that's done, and I want those students to do that for the same reasons exactly of what you're talking about. And I find the art students think that's easy and they understand it. The science students think it's a waste of time. And I'm like, this is why you need to do it, right? So it's a challenge getting people from these different backgrounds, even in academia, to come together and understand why they need to do this stuff. But it's radically changed everything that I do and my whole approach to this kind of work. Even the way that I write about it. I look at the old papers I first started writing about and I read back them like, oh, God, I could just... The work had in some importance, but the way that I wrote about it was horrific. And part of that was based on the journals and the editors. So I'd write papers about, I was curious, like, I don't know, what do Aboriginal people across Australia know about comets, meteors, meteorites, eclipses? I'd write papers on all that. But the journal said, the editor said, okay, Duane, what you need to do is give some background, talk about the physics of the phenomena, and then talk about the cultural perceptions of it. And what that did, I didn't realize at the time, it says, what we really know about the stars is the physics behind it. And here's the cultural interpretations. How close did they get to knowing this knowledge? And it was putting them on these different levels, right? And that was completely the wrong way of doing it. Because it's not about trying to compare them or fit them into each other. It's knowing there's going to be like a Venn diagram. There's a crossover between them, but they're different systems of knowledge. And I no longer write about it in that way, you know, where you have this sort of weird hegemonic positionality of how one's better than the other, because they're not, right? So a lot of that's happened in that regard. So if you go back and read my own papers, please have mercy.
Yeah, my question sort of relates to, you mentioned some of the places that you go to, some of the knowledge is secret and remains within the communities. I'm just wondering how much of that knowledge that is kept secret within the culture, do you think the people would be willing to slowly bring out to the open to share, or is that something that will remain within the culture themselves? And maybe our visitors might be able to...
I think Uncle would be a better person to ask that question to.
I can only talk of my experience, both up in the north as far as Darwin and across to the west, dealing with different cultures. I've never yet run across an elder that doesn't want to share. That is our role. We are blessed to be classed as an elder, apart from the respect that we receive from everybody. I am learning knowledge from the ones that I'm supposed to be teaching, because my culture was taken away from me at 15 years of age. I didn't reconnect until I went to a massacre site at Mile Creek, and the old people spoke to me, and I started to pass them. And I always knew I was Aboriginal, but not allowed to talk about it, because I was born in 1938. The 50s and 60s was horrendous. Written his cultural ambassador there. I'm getting worked up about it, but it was pretty horrible, so I wasn't allowed to be Aboriginal. But however, now that I've reconnected over the last 5-6 years, I'm still learning, I will share every bit of my knowledge, and so will these others next to me here and these young'uns that are growing up. And that is our role in life as elders, is to help our young'uns understand and to be proud of our culture.
I just wanted to add to that, that it is, like Uncle John said, completely different, depends on who you talk to. So we could only speak for our own communities, like as mob, and you would have found that going through all these communities, and there's reasons why we don't share everything at this point. Even language sometimes. Programs that we work on, we are trying to share this knowledge with our communities first, because they lost that. So especially our young people, before we share it to other people, you know, because you'd hate for someone else to learn like Yorta language before you get to learn your own language. So it's really sensitive, but it's completely different across 38 different language groups here in Victoria, and every single person from different family groups, once again, will have different insights on that as well. So you've always got to make sure you're just talking to the right person in that community. But hopefully, we hope that one day we can share everything. That's the plan. But also, people take a lot of knowledge and write books about it, not you, like you were talking about the explorer. Yeah. So we've got to be really careful about losing a lot of that to people taking it and making it their own. So it's really sensitive, but yeah, depends who you talk to.
Well, Uncle Gillar here said that he was sharing this knowledge for the first time, where traditionally it was much more secret. But he says now is the time that we need to be sharing this. So there are a number of elders who are saying, look, in traditional times, we probably wouldn't have shared all this, but some of this we are going to share. So certain restrictions are being lifted over time, but there's still parts of Australia like, nope, you don't talk about certain areas, certain places, or some of it might be interesting for people to know. It may be just certain times of the year you can't talk about something. Might just be a certain time of the year. And we think about, like stars, for example. Stars have a name, constellations have a place in the sky, in Western stuff. But in First Nations context, a star can have multiple names. Constellations can overlap and have different meanings depending on the context of what you're talking about. So the same thing can happen with the knowledges themselves. Elements of it can be open, certain parts can be secret, but sometimes it's just the time of the year that you talk about it. So elements of this, with the creation ancestor, you weren't supposed to say their name between the months of October, or between months of March and October. You're supposed to use an alternative name. But outside that, you can say the name. So it just depends. So it can get quite complicated, but the elders are sharing a lot of knowledge now.
Based on your experience within Australia, have you had the opportunity to look at other myths and cultures across the globe that might have similar but different stories, right?
Yes. It's remarkable. That's one of the amazing things about this work. You see, not only these themes almost apply universally, but remarkably similar instances of the same groups of stars having the same interpretations by cultures separated across space and time. So the Seven Sisters, the Pleiades, Orion chasing the Pleiades, you see around Australia, you see around the world. Gemini being twins, two brothers, you see around the world. You see it in Tasmania. The emu in the sky, which I didn't speak about because I feel we've spoken a million times about the emu in the sky, right? You find that not only across Australia, but you find it in South America. So there's the ray in the sky. Tupi people, Quechua people, Northern Chaco people all have the same large flightless bird, same shape in the sky. The stories might vary about how and why it came to be in the sky, but what it tells you is almost universally the same. Now, a PhD student working with me, Bridget Kelly, did her entire doctoral thesis, which she's writing up now, in psychology to answer this very question. Why is it the same groups of stars are seen by different cultures? What's the common denominator? Our perception, psychology, right? That it seems to be a matter of human perception, the way that we use Gestalt principles to group things into patterns and to recognize them, and the way knowledge is shared across cultures could help explain this. We don't have a one answer meets everything, but she certainly pulled together quite an interesting study of that. So it's an ongoing situation. But yes, there are remarkably similar stories around the world and similar views of even the same groups of stars around the world. So Orion, Northern Hemisphere, Orion chasing the Seven Sisters. A lot of cultures in Australia talk about it being a man. They say in Australia he's upside down. Right? He's upside down. And in the Wiradjuri they say he's upside down because he was hunting after emu and he tripped and fell over the horizon. That's why he's upside down. Right? So kind of incredible stuff when you really look at it.
Wouldn't you say that Western cultures and the indigenous cultures have been separate and independently developing till the Western men arrived in Australia? They've been separately developing, but both in their science, they have both been driven by curiosity, but also the need to be functional as societies. And I see it's very much so in Aboriginal society that recording system by myth has been a means of not just passing on knowledge, but as a result of staying functional and cohesive and progressing as a community.
I am very cautious about trying to speak on what Aboriginal people think about your own knowledge, but I mean, there is the practical function of that, of course, because that has to be there. You need that. That's required. But funnily enough, we're going to end on this because I know people are getting, we've been here for a while and we've had a lot of fun chatting about stuff. A seminar was given yesterday by a colleague, Tom Davies, who's a lecturer in ancient world studies. He was talking about ancient Babylonian and Akkadian texts. And he says, we've got these ancient records full of mathematical and historical records of astronomy. He said they didn't seem, by everything they can see, there seemed to be no real interest in astronomy as, isn't this cool to study it? Isn't this neat? We feel fascinated. It was very pragmatic. And one of the reasons it was so pragmatic is just beyond the calendars and stuff, were things like the fact that the kings believed that certain types of celestial phenomena, in particular eclipses, had very important meaning for them that was usually bad, and they wanted to know when they were going to happen. I talked to the class in a lecture earlier that week. Coincidentally, I said ancient cultures didn't do everything because it has a calendar function to it. There might be other motivations. What would your motivation be if you were a court astronomer for one of these kings who felt that he could be dethroned if an eclipse was going to come, and he told you he wanted to know when the next eclipse was going to happen? What's your motivation? Keeping this attached to your body? Probably pretty good motivation, right? And they did that. They were very successful at that. So different motivations, different reasons. But yeah, I mean, we've all got a curiosity. But like I said, the stars are an ever-present thing that we can go to, and that's why we relate to the stars in this really primal way that we do. It's also why whenever we see something that isn't normal happening in the sky, we tend to freak out about it and think it's something really bad. Comets, meteors, eclipses, supernova, things like that usually are seen as something kind of negative for that exact reason. But there's a lot of really amazing stuff in the sky. But if you want to know what Aboriginal people think about their knowledge, ask Aboriginal people what they think about their knowledge.
Local Peninsula product.
Oh, thank you so much.
For you to enjoy. And I know there are two of you here today, so you get a hat and a beanie.
Ooh, all right. Awesome.
Yeah.
Thank you so much.
Thank you
Cheers.
very much. Thanks,
Appreciate
mate.
it.
Thanks for coming.
I love how in Australia, how alcohol is currency.
Let's have a beer, get some done. That's right. Thanks so much.
Yeah, a quick comment or two.
Yeah.
Your question about Stonehenge. I have seen a photograph from Duane. There are rocks, and I don't know whether they're the ones he was talking about, down near the UoM.
Yeah.
In that photograph, I've seen the power lines, and every time I'm driving down John Road, I'm trying to work out exactly where
it might have been. Yeah. I also remember seeing something mentioned on a television program.
protection of those stones.
Yeah.
So that's the about.
Entirely understandable. Yeah, entirely understandable. All right, we'll look at the lost Apollo missions. This goes for about 5 minutes, and then we'll close.
We all know the final Apollo lunar landing mission was Apollo 17, but what if it hadn't been? What if NASA had had funding to not only see Apollo through to Apollo 20, but also fulfill its post-Apollo goals? We're doing a bit of a thought experiment today on Vintage Space. In July of 1960, there were many within NASA already looking beyond the immediate Mercury program, looking at long-duration lunar missions, orbital space stations, and even manned missions to other planets. Fast forward less than a year, and President Kennedy promises the nation a manned landing on the moon by the end of the decade. In the years that follow, the Apollo hardware and missions start to take shape, and there were already lofty plans being made to push that hardware beyond the immediate goal of the moon landing, to fulfill these goals of space stations and manned missions to other planets and long-duration moon missions, including building a base on the moon. So why didn't we see any of this happen? And more interestingly, what did we miss out on? Well, there are a couple of ways to look at this question. And because it's all within the umbrella of the Apollo program, more or less, we have to look at them sort of in tandem. So the two sides are the cancelled Apollo lunar landing missions and the cancelled plans to push that hardware beyond the Apollo program. So let's start with the unrealized lunar landing missions. But first, let's backtrack just a little bit. Apollo took shape in the background as Mercury and Gemini solved all kinds of problems of living and working in space, and so too did the outline of how the missions would proceed. They were all given a letter to denote the mission type. A missions were unmanned Saturn V and Command Service Module flights. B missions were unmanned lunar module flights. C missions were manned Command Service Module evaluation flights in Earth orbit. D missions were manned Command Service Module and lunar module development flights in low Earth orbit. E missions would be manned CSM and LM tests on a simulated lunar mission. This would see the spacecraft flying in a highly elliptical orbit around the Earth, hitting a peak apogee of 3,500 nautical miles. F missions would be the dress rehearsal before a manned lunar landing. The G mission would be the first attempted lunar landing. H missions would be longer duration stays on the moon, up to 2 days with 2 EVAs. I missions would be long-duration Command Service Module only lunar orbital missions designed to survey the moon up close. And finally, J missions would be longer 3-day stays on the moon with an extended lunar module, 3 EVAs, and a lunar rover. So a lot of those mission types should sound more or less familiar, but as we know, that original plan sort of fell apart. There was never an E mission, and when it turned out that the lunar module was falling behind schedule compared to the command module, Apollo 8 became a sort of C' mission, going to the moon with the command service module only. But still, even when Apollo 8 was flying, NASA was planning to go to the moon through Apollo 20. Well, these missions were never completely planned out to the last detail, and no crews were ever formally assigned to these last 3 flights. But based on what work was done to plan these missions and regular flight rotations, we can get a bit of a glimpse into what these missions might have looked like. Apollo 12's Dick Gordon might have commanded Vance Brand as the command module pilot and Jack Schmitt as the lunar module pilot on Apollo 18's mission to Copernicus. Commander Fred Hayes would have led CMP Bill Pogue and LMP Jerry Carr to a landing at Hadley Rill. And rounding out Apollo, Pete Conrad might have commanded his second crew to land on the moon, with Paul Weitz as the command module pilot and Jack Lausma as the lunar module pilot, landing at Tycho. But maybe not. There's also some speculation that since it would have been Conrad's second landing mission, Stu Roosa, Apollo 14 CMP, might have been given that coveted commander spot on the final Apollo landing mission. But this fell apart pretty quickly after Apollo 11 landed on the moon in 1969. Apollo 20 was the first to go. This mission was cancelled in January of 1970, so before Apollo 13's near disaster in space, but already when NASA was feeling stricter budget constraints on the program. Next to go were Apollos 15 and 19. Apollo 15 was originally on the books as an I mission, but NASA realized it could fold those goals into a J mission, and so it cancelled the last 2 J missions and updated Apollo 15 to be a J mission. So changing goals and dwindling budgets killed the last 3 Apollo missions that would have put more emphasis on understanding the geology of the moon. But it wasn't the only casualty of NASA's dwindling budget as the decade wore to an end. The other thing to go was the Apollo Applications program that started life as the Apollo Extension Series. In April of 1964, the Apollo Logistics Support System Office was established to look at ways Apollo technology could support post-moon landing goals. Broadly, the office looked at using Apollo hardware for unmanned missions, for the first steps towards a space station, and to lay the groundwork for long-duration lunar missions. By 1965, these distant goals were formally on NASA's books under the Apollo Extension Series, retaining the cachet and potentially the funding levels of the Apollo program. And NASA had some pretty lofty goals for these initial missions, and it all hinged on using an upgraded spacecraft, namely the Command Module. A Block 2 command module was the one that went to the moon. The Block 3 would be for the Apollo Extension Series, and it would have some significant advances. One of the main experiments under the Apollo Extension Series was to be the Apollo Telescope. This would be a dedicated solar observatory that astronauts could use to make detailed observations of the sun from outside the Earth's atmosphere. There would also be a host of experiments on board, including biomedical questions, behavioral questions, questions concerning artificial gravity, living organisms in space, the behavior of liquids and gases in space, and astronaut observations and EVA development. The lunar module could also be used for other non-landing missions around the Earth and around the moon, and could start building the framework for a worldwide communications resource, and also just be used to fly packages of instruments. There was also some talk of using the lunar module as the anchor point for that Apollo telescope. Basically, the idea was to leverage the lunar module's extremely reliable propulsion system into these longer missions, even if the spacecraft itself was designed specifically just to land on the moon. Using the Block 3 Apollo Command Module with or without a lunar module or some kind of environment module added, NASA was looking at missions in Earth orbit lasting up to 6 months and missions in lunar orbit lasting up to 6 weeks. As the Apollo Extension System developed, it took on a new name, the Apollo Applications Program, and the emphasis of this program was clearly on science, not on the technology. But the Apollo Applications Program started coming under fire from Congress in 1967. The whole program was deemed too lofty in its goals and not organized enough in terms of its structure and management. And so as NASA started feeling the pressure of losing funding to Apollo, AAP became one of the earliest casualties. Only one goal from the whole Apollo Applications program survived. While NASA was looking at these long-duration Earth orbital and lunar orbital missions, there was also growing interest in using an S4B stage, the third stage of the Saturn V, as an orbital laboratory. This, of course, became the Skylab program. So if Apollo hadn't lost its funding, we would have 3 geology-heavy lunar landing missions and long-duration Earth and lunar orbital missions and Skylab. So at least we got Skylab.
Now we'll close with this video that's released by the NASA Scientific Visualization Studio about the end of each year. I put that cartoon on the left there that is showing the apparitions of Halley's Comet coming round, because someone at one of the public nights in January actually came up to me and said that their newborn son, he actually showed them Halley's Comet and said, I intend to be around with you to see it when it comes back. And so he was actually doing exactly as that cartoon shows there. Now this video goes for a couple of moments, and it'll show you all the Apollo landing sites there and what the moon looks like for every hour of 2026. So you can go to this video, stop it at any frame and see what the moon will look like at any day, any hour. And what?
Have a heritage listing. Should be heritage listed, otherwise the Chinese or the Russians will blow it up.
Heritage listing of the moon, yeah, that's an interesting idea, Roland, yeah. I'd also like to thank Phil Peters for inviting the Willum Warrain people along to that talk as well, because it was good to see them there. That's a good question. I thought we had one, but if we haven't, we need to get one. Yes, that's right. I shan't look now. All right, and with that, I'll close the meeting, and hopefully we'll see you with the February meeting. All right, thanks for staying.